ever wonder where all the waste that we flush down the drain ends up? Today we are visiting the sewage water treatment plant of the city of Graz. An 825-kilometer-long sewer network collects and transports the wastewater from households in Graz to the facility, where it gets purified and recirculated. Although the flow of wastewater is constant, the overall process is discontinuous, and it's divided into 3 main stages. Firstly, the wastewater passes through the mechanical treatment stage. It enters the screening system where all solid components larger than 6 millimeters are eliminated and dewatered in a screening wash press. There, they are washed, dried, and cut into small pieces. This makes their transport and further processing easier. In the aerated sand and grease trap, the fine sand content and the dissolved grease are removed. The slower flow allows sand to sink to the bottom, whereas fatty compounds float on the surface. This is followed by the pre-treatment tank, the last step of the mechanical treatment stage. Here, the water's flowing speed is reduced even further in order to let the suspended particles settle to the bottom. In the biological treatment stage, microorganisms, for example minute living organisms such as bacteria, fungi, etc., break down the contaminants dissolved in the wastewater. This process takes place in 3 separate tanks. In the first tank, the wastewater is mixed with sludge which contains bacteria and other microorganisms. The resulting homogeneous mixture is then passed to the second tank, where it gets oxygenated. Higher oxygen levels and regulated temperature provide the ideal conditions for bacteria to grow and multiply. In the third tank, the microorganisms feed on the contaminants, essentially carbon, nitrogen, and phosphorus compounds, converting them and eliminating them from the wastewater. During the biological degradation, flocculating agents are added in order to facilitate the separation of water and sludge. For example, iron solved in hydrochloric acid binds the phosphorus content by building heavy complexes that sink faster to the bottom. Finally, in the after-treatment tanks, the sludge is separated from the water by means of sedimentation. This requires a slower flow rate. In these tanks, the dwell time equals the settling time. Thus, contents of different densities are separated. The sedimentation time depends on the flow rate and the size of the dumping area. The resulting clean water discharges into the River Moor. The deposited, activated sludge is then pumped back into the first tank of the biological treatment stage, ensuring that the population of microorganisms is always appropriate. Biomass is removed as surplus sludge and fed into the digester, where it rots for about 3 weeks. The released methane, carbon dioxide, and other gases provide about 70 to 80% of the energy requirements of the entire plant. This concludes the cycle of how sewage in Graz is purified and recirculated.